All right, so the density of water is 1 gram per cubic centimeters. An object will float on water if its density is less than the water's density, and it will sink if its density is greater than the water's. So for number 12, suppose a line with a mass of 90 grams is in the shape of a sphere with a radius of 2.5 centimeters. We want to see if the line will sink or float. So we're going to need to find the volume of this sphere. The volume is 4/3 pi r cubed, so pi times 2.5 cubed. So I wind up with 2.5 cubed times a 4/3 times a pi comes out to be approximately 65.45 cubic centimeters. So now we want to find the density of the line, and that's going to be approximately equal to the mass of 90 grams over the volume So a 90 divided by a 65.45 is about 1.38 grams per cubic centimeters. So since the density is higher than the density of the water, then it will sink in the water. All right, moving on to the next one. Imagine you have a baseball and an apple the size of a baseball. The baseball has a volume of 200 cubic centimeters and weighs 145 grams, while the apple has the same volume and weighs about 100 grams. Which object is denser or more dense? So we're going to do the baseball first. The density is equal to 145 grams over 200 cubic centimeters. So it is 0.725 grams per centimeters cubed. Now I'm going to do the apple. So the apple's density is equal to 100 grams over the same volume. So 100 divided by 200 gives us that the apple's density is 0.5 grams per centimeters cubed. So which object is denser? That means which object has the higher density? That is the baseball. Okay. An aquarium shaped like a rectangular prism has a length of 30 inches, width of 10 inches, and height of 20 inches. We are going to fill the aquarium 3/4 with water. So what is the volume of the water? So I need the new height of what I'm filling it to. So if I do 3/4 of the height of 20 inches, then that means I'm filling the water all the way up until it is a height of 15 inches. So finding the volume then, in a rectangular prism, I'm going to do the length times the width and times the height, which is 15. So 30 times 10 times 15 comes out to be 4,500 inches cubed. Okay. When you submerge a rock in the aquarium, the water level rises 0.25 inches. We want to find the volume of the rock. So basically, what we want to do is we want to find the volume of the rectangular prism, but with the height of 0.25 inches. So 30 times 10 times 0.25 will give us the volume of the rock, which is 75 inches cubed. How many rocks of the same size as the rock in part B can you place in the aquarium before the water spills? So if I find the volume of the whole aquarium, which would be 30 times 10 times the height of the whole aquarium, which is 20, that will give me the volume of the entire aquarium filled to the very, very top, which is 6,000. Now, I only filled the aquarium up to a height of 15 inches. So if I do 6,000 minus the volume that I have already filled my aquarium to, which is 4,500, that means that I have 1,500 cubic inches left in my tank until the water gets to the top. So I want to figure out how many rocks I can submerge to fill up the rest of that 1,500. And so each rock has a volume of 75 inches cubed. So if I do the number of rocks times that volume, I want it to equal the 1,500. So then if I do 1,500 divided by 75, I get x is 20. But that's how many rocks it would take to fill it to the very, very top. I want, and yes, it says, can you place in the aquarium before water spills? So that is exactly what I want, 20 rocks. What shape might best model the rock? We're going to use the volume from part B to create possible dimensions. A rock is typically in the shape of a sphere. So the shape that might best model the rock would be a sphere. And now we need to find the radius of our sphere in order to find the dimensions of the sphere. So the volume of each rock is 75. So if I set 75 equal to the volume of the sphere formula, which is 4/3 pi r cubed, I can figure out what the radius would be of each of these rocks. So if I do 75 times 3 divided by 4, that's a 56.25, and then that's equal to a pi r cubed. So now I'm going to divide both sides by pi, and I get a 17.90 is approximately equal to r cubed. And then taking the cubed root of both sides, r is approximately 2.62 inches. All right. if the density of the rock is 0.0025 ounces per inches cubed, we want to find the mass of the rock. So my density is equal to mass over the volume of the rock, which was 75. So then I'm going to multiply both sides by 75 to get that the mass is equal to 0.1875 ounces. All right, that brings us to the end of this video.